Okay, so now what we're going to do is do two things. We're going to look at the derivative of some simple trig functions like sine and cos, and we're also going to look at the chain rule, which is a very commonly used rule in differentiation. So first of all, if you have the trig sine function, and you are going to take the derivative of this, so I'll just write d by dx to show that I'm going to take the derivative of sine x, that simply just becomes cos x. And if you take the derivative of cos x, well, that simply becomes negative sine x. So these are our two trig derivatives. And now looking at the chain rule, which comes up quite often. So chain rule. Okay, so let's say you are going to differentiate a function within a function. So this is our inside function g of x, and this is our outside function f of x. So the rule stipulates that you differentiate the outside function and you leave this inside function unaltered, and you multiply it, and I'm just using a dot to indicate that I'm multiplying. You multiply this by the inside function differentiated, and that's it. So simply take the derivative of the outside, leave the inside function unaltered, and multiply it by the inside function differentiated, and that's the chain rule. So what I'm going to do is I'm going to show you an example of the chain rule being used for a non-trig function and then being used with several trig functions, just to show you how we use a chain rule here. So let's say my first example, so I'll call this example 1, is simply going to be y equals 3x to the power of 5 plus 2x to the power of, I don't know, 3, and all of this is to the power of 4. Okay, so I just came up with that off the top of my head. So you could obviously use binomial theorem, binomial expansion to expand this out and use then do the derivative then, but far too complicated. Far easier to simply use the chain rule here. And if you're wondering what the binomial expansion is, don't worry about it. It's not something you need to know just now. So you bring the power here to the front and you multiply it by the coefficient, which is 1, essentially. That's going to become 4. You leave the inside function unaltered and you reduce the power by 1. So this is going to remain exactly as it is with no change at all. Like so. And then you multiply. So that's the first part we just did. We differentiated the outside. We did not change the inside, and we're going to multiply this, and you can use a dot, you can use a cross, it really doesn't matter, whatever you prefer, and you multiply it by the inside differentiated, and you simply just differentiate that as you normally would, and you differentiate this as you normally would. That's just going to be multiplied by 15x to the power of 4 plus 6x squared. And you could tidy this up, but I'm not going to do that because it's not necessary here. I simply wanted to show you how to use the chain rule to differentiate. So let's use the chain rule to differentiate some trig functions. Some complex trig functions, or slightly more complex trig functions. So suppose I'm going to differentiate something like, I don't know, y equals sine to the power of 4x. Well, you can differentiate it the way it is. You can. However, I'm going to rewrite it to make our lives a bit simpler, because right now a lot of people will look at this and not realize what the inside function is and what the outside function is. So for example, obviously the g of x is the inside and the f is the outside. What's the g in this case and what's the f in this case? So if I rewrite it this way, and this is the same thing. These two are the same things as each other. It's just a lot more apparent that sine x is now the inside function and the power of 4 is the outside function. So if I differentiate this, so y dashed is going to be 4. That's going to come down to a power of 3. You don't change your inside function, and you simply just multiply this by the inside differentiated. and that's it. There is nothing more to it than that. So tidying that up, it's just going to become 4. The cube, I'm just going to put it back where it normally would be with a sign. Like so. And just write cos x. You can write a multiplying between if you wish. Not necessary. And that's a chain rule being used in that situation. Let's do a couple of more ones. Now, actually, before I do some more different ones, a lot of people confuse this with this. Sine 4x. So here we have sine to the power of 4x. Here we have sine of 4x. Well, how do you use a chain rule in this situation? Well, again, I'm going to rewrite it just to make my life a bit simpler so I can see what the inside function is, this, and what the outside function is, this, the sine. Okay, so using the chain rule here, you differentiate the outside function. You do not change what the inside function is. And notice there's no powers here. I'm not reducing the power by 1. I'm not doing anything to the powers. Why? Because, well, when you have a simple sine to the power of 1 or cos to the power of 1, there are no powers that change here. So that's that bit. And you'd simply multiply it, and this time I'll do a dot to do something different. Multiply it by the inside, differentiate it. And that's it. Differentiate 4x, you just get 4. Tidying that up, that's going to become 4 cos 4x. And yes, you can bring the 4 to the front. In multiplication, you can do that. And I'm not going to put brackets in because they didn't in the initial question. I like to always leave my answer in the similar form to I was given the question in. So that's that. Let's do another one. Let's see. What could I do here? Let's do a cos one. Let's do a cos one that involves chain rule. So that involves, I don't know. Let's just do cos to the power of 3x. So same as before, same as my sine. I actually need to rewrite it. So that's going to be cos x all cubed, and now it's in a form that I can differentiate quite easily. So that's going to be y dashed. That's going to be, you bring the power down, 3, do not change what's inside the bracket, you reduce the power by 1, so that's the outside differentiated, and you multiply it by the inside function differentiated, and that will simply become negative sine x, like so. And if you wish to tidy this up, that's going to be, and the negative can actually come and join the 3 here, so it can actually become negative 3 cos squared x sine x, just like so. And some people would want to leave it the negative with the sign. Fine if you wish. However, it's far better and far neater to pop the negative with the coefficient here, and it's also better to take the square term and return it again to the form it was given to you in. Thanks very much. I forgot to mention earlier, a like would be greatly appreciated. If you have any questions or comments, please leave them down below, and as always, please subscribe. Thanks again.